Have you ever looked at the ocean and wondered what's happening beneath the surface? It's not just a quiet pool of water. Deep below, a powerful, slow-moving current snakes its way around our planet, the Atlantic Meridional Overturning Circulation, or AMOC. The AMOC is like Earth's circulatory system, pumping warm water north and cold water south, redistributing heat across the globe. Without it, our climate would be unrecognizable. The food we eat, the weather we experience, it's all connected to this silent engine. Scientists are now watching the AMOC with growing concern. Data shows this ocean engine is slowing down, weaker than it's been in over 1,000 years. This isn't just a scientific curiosity. A change in the AMOC could alter weather patterns, disrupt ecosystems, and affect billions. The AMOC helps explain why London is milder than cities in Canada at the same latitude, and why hurricane seasons can be so intense. It even holds clues to abrupt climate shifts in Earth's past. This isn't just a story for scientists, it's a story for all of us. The AMOC is the planet's hidden power, shaping our world in ways we're only beginning to understand. As we face an uncertain climate future, understanding this system is more important than ever. The heartbeat of our planet is changing. Let's dive in and explore why that matters. So, what is the AMOC? Imagine a giant conveyor belt submerged in the Atlantic Ocean. It starts near the equator, where warm, salty water flows northward toward Europe. As it travels, it releases heat into the atmosphere, acting like a massive radiator for northern Europe. This is why winters in the UK and Scandinavia are milder than you'd expect. As the water cools and becomes denser, it sinks near Greenland and Iceland. This is the overturning in AMOC. The sinking water pulls more warm water north, keeping the conveyor belt moving. Once it sinks, the cold, dense water flows south, eventually reaching the Antarctic and spreading into other oceans. Over centuries, this deep water slowly rises back to the surface in a process called upwelling. The cycle then repeats, regulating our planet's climate. This conveyor belt has been operating for millennia, balancing temperatures and supporting life. It's a delicate dance of heat and salt, driven by simple physics. If this system falters, the consequences ripple across the globe. The AMOC is not just a current, it's a planetary engine. Its steady motion is crucial for the climate stability we depend on. But now, that motion is slowing. You might wonder, how does this affect me? The AMOC's reach is global. In Europe, it's the reason for mild winters. If it slows, Europe could face harsher, colder seasons. In the US, a weaker AMOC means faster sea level rise along the east coast, as less water is pulled away from shore. It also fuels more intense hurricane seasons, since warmer tropical waters aren't carried north as efficiently. The AMOC influences rainfall patterns worldwide, shifting the tropical rain belt and impacting agriculture in South America, Africa, and Asia. A slowdown could mean droughts in some regions, floods in others. The fingerprints of this ocean current are everywhere, from Boston's cold snaps to Paris's heat waves. Our weather, food, and water supplies are all linked to this hidden force. The AMOC is a global puppeteer, pulling the strings of climate and weather. Even small changes can trigger dramatic effects. Our interconnected world depends on its stability. When the AMOC shifts, so does life as we know it. The AMOC isn't just a steady current, it's a climate switch. Throughout history, this switch has flipped, sometimes with astonishing speed. When it's strong, we get the stable climate that allowed civilization to flourish. But when it weakens or shuts down, the climate can change dramatically and fast. Ice cores from Greenland and Antarctica reveal abrupt climate shifts, sudden plunges in temperature tied to changes in the AMOC. One example, Dansgaard-Oeschger events, when Greenland's temperature soared or plummeted by up to 15 degrees Celsius in just decades. These wild swings were linked to the AMOC turning on and off. The climate system has tipping points, thresholds where it can reorganize itself rapidly. The AMOC is one of the most critical of these tipping points. It's not a system where small changes mean small effects. It can absorb stress, then suddenly snap. Understanding these past flips is crucial as we push the system in new ways. The AMOC's hidden switch has shaped our world before. If it flips again, the consequences could be profound. We're closer to that threshold than we think. To grasp the AMOC's power, let's travel back 12,800 years to the Younger Dryas. Earth was warming, ice sheets melting. Then, suddenly, the climate reversed. Temperatures plunged, and the world was thrown back into near ice age conditions for over 1,000 years. The likely culprit? The AMOC. As North America's ice sheet melted, a massive freshwater lake burst into the North Atlantic. This flood of fresh water, less dense than salty ocean water, formed a lid on the ocean, stopping the AMOC's sinking process. The conveyor belt ground to a halt, and the climate switch flipped off. Greenland's temperature dropped by about 10 degrees Celsius, glaciers advanced, and forests died off. This event shows how sensitive the AMOC is to changes in the North Atlantic, especially fresh water. It's a chilling lesson: disrupt the AMOC, and the climate can change overnight. Today, Greenland's ice is melting fast, echoes of the past warning us about our future. The AMOC's history is a cautionary tale. We're repeating the experiment, but this time it's driven by us. The stakes couldn't be higher. The AMOC's influence isn't just ancient history. It's shaped recent centuries too. During the Little Ice Age, 1300–1850, Europe and North America endured colder, stormier weather. Rivers like the Thames froze, glaciers advanced, and harvests failed, leading to famine and unrest. While volcanic eruptions and solar changes played a role, a weaker AMOC likely amplified the cooling. Even specific disasters, like the Great Storm of 1703 or brutal winters during the American Revolution, fit the pattern of a sluggish AMOC. These events remind us that climate is not static. Our normal weather depends on a strong, stable AMOC. When it falters, chaos follows. Frozen rivers, failed crops, and social upheaval. The stories of the past are warnings for the future. Societies have always been vulnerable to the AMOC's whims. If it weakens again, we could face similar challenges, only now with far more at stake. The AMOC's tantrums have shaped history. They could shape our future too. Fast forward to 2025. The AMOC is at its weakest in at least 1,600 years. This isn't speculation. It's measured by ocean instruments and confirmed by sediment cores and ice records. Scientists track the AMOC's pulse with arrays of sensors across the Atlantic, and the data is clear. The slowdown is real and unprecedented. The main culprit? Melting Greenland ice, pouring vast amounts of fresh water into the North Atlantic. This fresh water disrupts the sinking process that drives the AMOC. Increased rainfall and river runoff in the Arctic add to the problem. We're repeating the same experiment that triggered the Younger Dryas, but this time it's driven by human-caused warming. The big question: how close are we to a tipping point? Climate models show the AMOC has a threshold. Keep adding fresh water, and it could snap. A complete shutdown soon is unlikely, but the risk is rising. Even a continued slowdown will have profound global consequences. The AMOC's fate is now in our hands. What happens next depends on what we do. A slowing AMOC isn't just a scientific issue, it's a real-world crisis. We're already seeing faster sea level rise along the US East Coast and a stubborn cold blob south of Greenland. For agriculture, a weaker AMOC could shift rainfall patterns, disrupt monsoons, and threaten food security for billions. Some regions could face droughts, others devastating floods. The global food system relies on stable weather, something the AMOC helps provide. Economically, the impacts would be massive. Fishing, farming, insurance, and coastal infrastructure all face new risks. Europe could see soaring energy demand for heating, while food prices spike worldwide. The cost of adapting to this new reality would dwarf the cost of prevention. Most importantly, a weaker AMOC means more extreme, unpredictable weather, heat waves, cold snaps, and storms in unexpected places. Our models and infrastructure are built for a stable climate. If the AMOC keeps slowing, the weather of the past won't predict the future. We'll face a world that's harder to live in and harder to plan for. The time to act is now. We stand at a crossroads. Our actions have put the AMOC in danger, but we're not powerless. The most important step: slow the melting of Greenland's ice by cutting greenhouse gas emissions. This means shifting to renewable energy, using less, and making sustainable choices in our daily lives. Individual actions matter. When millions act, industries and governments follow. But real change requires collective action, investing in clean energy, updating infrastructure, and enacting policies that make sustainability the norm. We must also adapt, building better sea defenses, developing resilient crops, and preparing for a less predictable climate. The AMOC is part of our home, not a distant force. For millennia, it's given us stability. Now, it needs our protection. This is a challenge, but also an opportunity to come together, use our knowledge, and act as stewards of our planet. The future of the AMOC isn't written yet. Our choices will decide what comes next. We can protect this hidden engine, or risk the consequences of letting it fail. The climate switch is in our hands. The time to act is now. Let's choose a future where the AMOC and our world can thrive.